All right, you got to hear this because what we're about to cover sounds like something straight out of science fiction. We're talking about maybe the most exotic and definitely the most volatile substance in the entire universe. Yeah, you heard that right. Scientists over at CERN, the European Organization for Nuclear Research, they took actual, real-deal antimatter. And they stuck it in the back of a truck. Seriously, no joke. Drove it around the campus like it was just another Tuesday delivery. I mean, how wild is that?
So, the big question is, right, why would you ever do that? Why put something so unbelievably dangerous on wheels? Well, the answer, it actually takes us all the way back to the beginning of time and to this huge mystery about why any of us are even here.
So, to get to the why, you have to think of the beginning of the universe as, well, like a cosmic crime scene. And there's a huge piece of evidence missing, a prime suspect that's vanished without a trace, antimatter.
Okay, so to crack this case, we gotta know what we're dealing with. You've got matter. That's the stuff that makes up, everything. You, me, this planet. Then you've got its bizarre twin, antimatter. It's basically a perfect mirror image. So for a proton, which has a positive charge, there's an antiproton that's exactly the same, but with a negative charge. It's like its evil twin.
But here's where things get explosive. When matter and antimatter touch, they don't just, cancel each other out. Nope. They annihilate each other. Poof, gone, in a massive burst of pure energy. We're talking total and complete destruction. And that right there, that's the heart of the mystery. See, our best understanding of physics, the Standard Model, it tells us that the Big Bang should have made equal amounts of matter and antimatter, perfectly balanced. But if that happened, everything should have immediately annihilated itself, leaving behind, well, nothing. Just a universe full of energy. No stars, no planets, no people. The fact that you and I are here, that we're made of matter, means something's wrong with that picture. Somehow, matter won. There has to be some tiny, tiny difference that tipped the scales.
And that's where our road trip comes in. See, to find that tiny universe-making difference, scientists have to measure matter and antimatter with insane precision. But there's a huge problem standing in their way.
Okay, so at CERN's antimatter factory, there's an experiment called BASE. That stands for Baryon-Antibaryon Symmetry Experiment. And they're trying to do exactly that. They're trying to measure protons and their opposites, antiprotons, with more precision than anyone has ever done before. They're hunting for any little wobble, any tiny discrepancy at all.
But here's the kicker. The place where they make this stuff, the antimatter factory, it's noisy. And I don't mean loud. I mean it's flooded with stray magnetic fields from all the other crazy experiments going on. Trying to get a precise measurement there is like trying to hear a pin drop in the middle of a rock concert. It's just impossible. The interference messes everything up. So what do you do when your lab is too noisy? Well, you can't just tell the other experiments to be quiet, so you pack up your experiment and take it somewhere else. And to do that, they came up with an absolutely brilliant, almost crazy piece of engineering. Basically, a trap on wheels. And here it is, the hero of our story, Base Step. The best way to think about it, it's like the world's most advanced thermos. It's a portable magnetic bottle, a container built to do one thing: grab onto antiprotons, shield them from, well, everything, and then take them on the road. So how in the world do you bottle up antimatter? It's a pretty wild process. First, of course, you have to make the antiprotons at CERN. Then, you wrangle them into this thing called a penning trap. It's basically a cage made of magnetic and electric fields. Next, you have to chill everything down to cryogenic temperatures, like insanely cold, to keep them from jiggling around. And then, you seal the whole thing up in a vacuum and surround it with magnetic shields. So, for their very first test drive with actual antimatter, the team managed to load up 92 antiprotons. Now, I know, 92 doesn't sound like a lot, right? But it was more than enough to prove that the whole crazy idea could actually work. And let's talk about that temperature for a second. To keep the trap's powerful magnet working, it has to stay below 8.2 Kelvin. That is colder than deep space. And that's not just some random number. It's a massive engineering hurdle you have to solve if you want to put this thing in the back of a truck. So, they had their high-tech thermos. They had their antimatter all loaded up. It was time to hit the road. This was it, the moment of truth. This whole thing didn't just happen overnight. The team started building this portable trap way back in 2020. They did a test run with regular old protons in 2024, and now they've done the real thing.
the first ever transport of antimatter. But the big prize, the ultimate goal, is a much longer trip. We're talking an 8-hour drive to a super quiet lab over in Germany.
This first test, it was pretty modest, but it was absolutely crucial. They just drove the truck around the CERN campus for about half an hour, going up to 42 kilometers an hour, hitting bumps, taking turns, the whole deal. And guess what? It worked perfectly. The trap held, the antimatter was totally fine. It proved the whole concept was solid.
But that next big trip, that's way harder. As the project leader, Christian Smora, points out, for an 8-hour drive to Germany, you can't just rely on pre-chilled liquid helium. It'll warm up. So they're literally going to have to mount a generator and a special cooler, a cryocooler, right onto the truck itself. It's this incredible mix of like mind-bending physics and just really practical, down-to-earth trucking logistics.
So, why go through all this? Why put antimatter in a truck? Well, the payoff is just huge. By getting this experiment to a quiet lab, the team thinks they can get measurements that are at least 100 times more precise than anything they can do at CERN right now. That is a gigantic leap forward. And it might just be the leap they need to finally see that tiny difference that explains, well, everything.
So it all comes down to this, doesn't it? Could something as ridiculously normal as a road trip, okay, a very, very high-tech road trip, finally solve one of the biggest mysteries of the cosmos? Why are we here? Why does anything exist at all? It's kind of amazing to think we might actually be just one truck ride away from finding out.